so we can all be on the same page, figuratively and literally. All right. Now, last week we introduced the notion of some language that we use in algebra, right? And it's sort of like a warm-up lesson, if you will. We've been talking about some basic stuff that you guys have probably already learned before. And we maybe talked about some things that you hadn't learned just yet, maybe some symbols, maybe some terminologies, right? And I left you off last week when we were talking about finding the least common multiple and following our order of operations. So the last thing I want to talk about today, or in this lesson rather, before we move into something new, is talking about the notion of substitution and the notion of what terms are and how to combine like terms. So that's my goal. Wrap this lesson up to discuss those two things, about substituting values into a function and about learning how to combine like terms. So two basic tenets of Algebra 1. So if you look at this first example I've got right here, example 6, right? It says evaluate the expression negative 3x squared plus 5x minus 1. You guys jot that expression down, okay? In your notes, jot that expression down. And what we're asked to do is we're asked to use substitution and say, all right, plug in x equals 2. Plug in x equals 2 and see what happens. So as a course of habit, what I want us to get into the habit of doing is when we plug something in for x, we want to use parentheses. Can you make a note to that effect? Say, when I want to use my substitution principle, when I want to plug something in, evaluate an expression for a given variable or variables, use parentheses. I liken it to, when, let's say, Tiago, I'm going to put you outside and put you to make you do some yard work, okay? And I've got some bushes, some shrubbery, let's say, that I need replaced, okay? And I say, all right, here's a shovel, go dig that hole. What's that hole going to look like shape-wise?
A circle?
Yeah. And then if you guys see my hands, the larger, the more that Tiago digs, the bigger that circle gets, and it starts looking like, as far as our little mnemonic device here, in math, it starts looking like what? What symbol do these look like? Parentheses. Yeah, parentheses. So if you're going to scoop out, if I told you, hey, dig out that x, get rid of that x, scoop it out, we want to, in its place, we want to use parentheses to drop in whatever new bush we're putting in there, okay? Maybe some rhododendrons or something like that. I don't know. But the notion is use parentheses. And when we do that, we'll keep the order of operations straight. We'll keep all signs straight. And it's just a simple matter of doing arithmetic up to that point. Alex, what do we get when we get through with our order of ops there? You got a number for me? All right, walk me through it. What do you want to do first? All right, so we actually don't want to do multiplication first. Think about Pemdas, that order of operations that we talked about last week. We got parentheses. There's nothing to be done there. And then what does that E stand for?
Exponents.
Exponents. So we're going to square that 2 first. So we got 2 squared is 4. And then I can multiply my negative 3 by 4 and get negative 12. Okay? 5 times 2 is 10. So we wind up with negative 12 plus 10, which is negative 2. Negative 2 minus 1 more equals negative 3. All right, that's the notion right there. We got a negative 3 as our answer. How about when we go through and we want to evaluate it now at negative 1? Okay, Mr. Jacobs, can you give me a value for negative 1s once you get everything plugged and chugged? Run those numbers real quick. Let's see if I can get some water and do that. All right, Jacobs, you got a number? Can you hear me? Maybe not. Jacobs, give me a some thumbs up if you can hear me. Lewis, can you hear me?
Yes, sir.
Oh, okay, good. Jacobs can hear me too. Mr. Jacobs, unmute your mic. Okay. Unmute your mic, James. Figure out how, there you go, that boy. Okay. So what number did you get when you in orange right here when you ran through and did your order of operations?
Oh, I haven't done it yet because it was lagging a lot, so I didn't know who you called on.
Oh, okay. Well, no worries. Here, well, let's walk through it together then. And Lewis, you can help me out a little bit too. All right. So what do I do first?
The exponent.
Good. -1 squared would be 1, and then 1 times -3 would be -3. Okay. So I got -3, -5, -1. What does that tally up to, class? -9 sounds good to me. So evaluating an expression should be pretty straightforward. Nate, question. If you don't have a pencil, Nate, you ask, and I shall provide you with one. Just because I'm that kind of guy. Once upon a time, I had a kid that his name's David Stanek. David made for me this giant. Nate, I'm gonna throw this at you. Okay, you ready? Oh, son. He made me this giant pencil ball. It was the coolest thing ever. It was literally like 100, and I think it was 162 pencils is what it took. But it was a bunch of pencils that were all in this big giant ball together. And you could pull one out, and the thing would stay in shape. And it had some rubber bands helping with that. But anyway, Paul, you had a hand up. What's your question?
Why does it say under -3 times 4, -1?
-3 times 4. I don't see a 4 on there. Right there in blue. What does it say where now?
It's under -3 times 4. It says -1.
Oh, I had started erasing it. That's -12. I had started erasing it, and I thought, I'll just leave that up there.
Okay.
Lewis, how about you, buddy? You had a hand up.
Oh, yes, sir. Why is it after -3 times 1 in the orange a subtraction? Like, shouldn't it? Because above it's addition.
Good question. Okay. So what we'll note that this is a multiplication that we do right here. So it's a +5 times a -1, and that's where we got our -5. Okay. And the parentheses, Nate, this is where you get up and go use the pencil sharpener, buddy. The parentheses help us to keep our signage straight. You know what I'm saying? So it helps us keep straight whether it's going to be positive or negative. And the parentheses really kind of help us do that. Okay. Any other questions? All right, Paul, go ahead and pull that hand down. Jack, what's your question? You good? All right. Now, when we go through and we talk about the word terms, okay? Terms are things that are added and subtracted. Can we all write that down? Terms are things that are being added and subtracted, added and or subtracted. Okay? And that's opposed to factors. Factors are things that are multiplied, right? Factors are things that are multiplied. Terms are added and subtracted. So the mnemonic device for that, right, is that the word term starts with what letter? T looks like what operator? A plus sign, right? That's a reminder for us. Okay? So terms are things that are added and subtracted. So like in green right there, I've got an example of a little trinomial there. It's got 3 terms. It's got 3 terms. 2x is the first term, 3y squared is the next term, and 5z over 6 is the third term. And those 3 terms are being added and subtracted. So therefore, they're terms. Now the word like terms, when I put what's that, an adjective? When I put that adjective like in front of it, like terms means that, okay, this is a specific way that we pair up terms. Okay? Like terms have 2 requirements. If you're going to combine like terms, it's like when I go to the store, okay? I go to the grocery store, and Teddy really likes, my son Teddy really likes Honeycrisp apples, okay? What's the problem with that? Has anybody ever gone to the store and bought Honeycrisp? What do you think, Joey?
They're
Are
expensive.
you a fan? Oh, somebody got it. Somebody said it right. Yeah, they're expensive. They're like $2.80 a pound. Whereas if I wanted to get a little Gala apple or a Fuji apple, that's like a $1.10 per pound. Okay. And so I tell Teddy, I was like, hey, Teddy, I got some apples. He's like, oh, Dad, are those crispy honey apples? He calls them crispy honey apples. And I'm like, oh, yeah, baby, they are delicious. And so I'll peel them up and I'll cut them up and I'll give them to him. But he don't know the difference. They got Fuji apples or Gala apples or Crips Pink or Pink Lady or whatever they are that are on sale. I'm not a barbarian. I don't feed the kid red delicious apples, okay, which are just gross. But does anybody know what a good apple to cook with is? What's a good cooking apple? Y'all don't do much cooking there. Reed? Granny Deckham Smith. That a boy. I knew somebody in here knew a good cooking apple. If you're going to bake a pie or if you're going to do something that involves cooking an apple, get a Granny Smith. Those green ones, they're great. They're not really nice to eat, like just raw, but if you cook them, oh mama, they're good. So suppose I go to the checkout lady at Kroger and I've got some Honeycrisp, I've got some Gala, some Fuji, and some Granny Smith apples. If I just dump all of those down there on the register, she's going to look at me like I'm crazy, right? Because although those are all apples, they are not the same kind of apple. They're not like that manner. So when we add terms together, when we want to combine terms, we have to check to make sure that they are like terms. We have to check to make sure that they are like terms. So that means that they are not only using the same variable, they're all apples in other words, but they all need to be raised to the same power. Mr. Perry, is that you out here out there? Maybe not. Thought I heard my neighbor, Mr. Perry, opening his door. It is. Come here. I want to. Do you notice anything different? You notice anything different? I'm trying it out. This is a little toy from Bill in Maryland. He said you turned your nose up at it, sir. Well, I told my seniors about it, and they said, you sound like the biggest dork. Everybody's going to laugh at you for wearing this. You know what? That's okay. That's okay. At least I don't have to yell all day. I'm talking in a nice, soothing tone. And these guys hear me. Hopefully they hear me. Brownlee, you still hear me? Yes. Okay. What about you guys at home? Y'all hear me all right?
Yes, sir.
Yep.
Yes, sir.
Now we're cooking. All right, so look, we're talking about apples, and we're comparing apples to apples, which is a fun little game, by the way, if you've played that little card game before. But I look at example 7. This is my last example in this section before we move on to start talking about something different. And I want to know if there are any like terms, if there's any pair. And I bet Andrew pick me a pair of like terms that I could combine there. All right, good. So if you didn't hear that, Andrew said 3x squared and 14x squared. We can put those two together and we add their coefficients. That's that C word right there. Coefficient just means the number in front of the variable, right? 3x squared, 14x squared, what do we get? 17x squared. Again, these are some basic tenets. Y'all ought to be thinking, oh, this is cake, this is easy. George is like, if all year is like this, I'm going to be loving it, baby. Okay. So we got our first pair of like terms. Okay. Josh, why don't you pick another pair for me, please?
12x plus 8x.
All right, easy enough. We got 12x. We got 8x. So again, we're going to combine the coefficients and get 20x. Last but not least, we've got, what is that, 11 and 5. So we got 16. Adding like terms, y'all probably did that last year in pre-algebra or whatever. Okay, easy peasy lemon squeeze. Now, it will get more complicated when we start involving, multiple variables, when we start involving some other operators, right? But for the basics right now, we're looking at the same variable, right? Raised to the same exponent, 4 exponents. Any questions about this first lesson? Paul, mute yourself, buddy. You get some feedback coming in.
Oh, okay.
Any questions at all, you guys?
Are we gonna go over the homework?
Absolutely. So when we talk about some of the basic tenets that we've discussed, we put them in action on the aforementioned homework assignment, right? Which you guys did for me over the weekend, or maybe. You weren't able to access the online book. Is that because you did not have access to the internet? Really? Okay. Well, let me walk you through. If you didn't hear that at home, we had one student had a problem accessing the textbook online. So here's what we're going to try it again, and I'll get you to try it again as well. Because really, all this is just a website. If you can get to, like YouTube, if you can get to Google, if you can get to whatever website you frequent, then you ought to be able to get to this. It's through a website called OpenStax, OpenStax.org. Okay. And I bookmarked it on my end. Like y'all see these are my 3 textbooks for this year. So I bookmarked it. But let's just start from scratch. Okay. So we go openstax.org. We hit enter. And then we're going to go up and we're going to pick out of the math section. Okay. We're going to pick the math section.
I gotta go.
You got to go?
Yeah.
Okay. No worries, man. Hey, catch the rest of the lesson online later. We got about 10 minutes, 15 minutes left.
All right. Thank you.
You bet, man. See you later, Paul.
Bye.
All right, so you see up under here, subjects, Mr. Went pick math, and then we're algebra, intermediate algebra, 2nd edition. It's just a website. Okay, if you can access the internet, it's this one right down here, and that's where you'd click on it. Ideally, we download it to our device. You don't have to if you continually have access to the internet at home. It is big time slow today. I wonder why it's being so slow. Anywho, it'll take, you can either browse it on the web by, doing the view online option, click the table of contents, what have you. It'll take you to the first section, and Alex, you can just go back and work it once you get that successfully accessed. But that first section, what did I have you do? 7, you get the same there as Max. Where is Oxley at? Do I see him online? Yeah, there's Jake. So what were some questions that you guys might have had over the homework? Anything you wanted to ask? Yes, no, maybe? Is this pretty easy? Good. Am I going to take it up? No, I'm not going to take it up. Once in a while, I'll give you all a homework assignment, and it won't be for like take up. It'll just be, did you do it? Okay, great, moving on. And then other times it'll be where I give you one through a website, either Delta Math or Albert or something like that, where it will actually, check the homework and I can get an accuracy grade on you. Here, this is just completion. Did you do it? Now bear in mind, once in a while, I like to give you guys a little quiz over, questions from the homework. And I believe I tried giving you guys a quiz last week through Microsoft Teams, and there were some issues with that, right? What was y'all, give me some feedback on y'all's experience with that.
It was easy after you posted like the link.
Hold on, I got 2 guys talking. So easy after I posted the link. Jack, what'd you say? Couldn't get on Teams at all. Is that still the same issue?
Yeah.
All right. So like I've got our tech guy, Mr. Donato, is like super smart about this type of stuff. I emailed him last night because I got you and there's a couple other that just have not been able to get it done. And that's no fault of your own. I know technology issues are frustrating. So you guys that are in class today, anybody else that have y'all had issues getting on Teams at all? Okay. Can we talk shop real quick? Like what type of device are you using? Microsoft Surface. Okay. Is that like personal device or school device? Personal device. What are you guys here in class accessing it via? Personal devices?
Yes.
Okay. And you guys online are obviously doing it on personal devices. All right. Did you guys have to add like the Teams app, or are you guys accessing it through the internet?
The Teams app.
Yeah, the Teams app.
Okay. Most of you guys using the app, and so again, this is going to be a Donato question probably, but like, do you have access to like Word and Excel and like those Microsoft programs on your Surface Pro? Okay. Check and see if you've got a subscription to where you can have those programs like Microsoft Word, where you like your word processing document. You probably have access to Teams one way or another, and it's just a matter of getting you hooked up. But anyway, I sent some emails to him last night, and I look to getting some responses this morning so we can get you guys squared away. So don't sweat it right now. And then Lewis, the feedback I heard from you was that Like once I emailed the link, you guys just clicked on it and you were able to take the quiz that way. It's just access to the internet, you get it?
Yes, sir.
What I will typically do then is when I want to give you guys a quiz, I will give it to you through not Teams, but just through the internet. Okay, to where if you've got access to the internet, all you have to do is just check your email, click a link, and you're good to go. So you guys won't have to hassle. And we'll get the team squared away one way or another, for sure. Okay. All right. Before you go, I want to talk a little bit about absolute value. Okay. So I'm gonna click on this slide right here, and I want to talk with you guys about absolute value. Something that you've heard of before, no doubt. Okay. You can probably calculate it. Like if I asked Will Edwards in the back, and if I said, Will, what's the absolute value of -4? What would you tell me? +4. And if I asked, if I asked online, Joe, what's the absolute value of 3? Joe's going to tell me what?
+3.
+3, right? And the notion that I oftentimes will hear, like you guys saying, Joe, that's a stellar haircut, by the way, bro. The notion that I'll hear you guys saying is what? Absolute value measures the what? Distance from 0 on a number line. That's what a lot of guys will kind of reference it as. I also hear once in a while, I'll hear somebody say, absolute value is the value of a number regardless of its sign. That's another way I've heard it expressed, right? Did you guys write either of those statements down? I didn't see many pencils moving. I'll say them again just for your edification. A lot of times I'll hear students, they'll say the absolute value of a number is the distance that number is away from 0 on a number line. Easy enough, right? And then sometimes students will say, hey, it's the value of a number regardless of its signage. Okay? So you can think about a bank account. A bank account, if I've got -$4 in my bank account, that's very different than having +$4. So there are certainly contexts where the sign matters, but then there are also some other contexts where the sign doesn't so much matter. Okay? And absolute value can be helpful. There's also another way of looking at absolute value, and this is what I'm going to leave you with today here in the last 2 or 3 minutes. Okay? And that is what's called a piecewise definition. A piecewise definition. Okay? So if you look right down here, where we're focused at right here, okay, is probably your first look at a piecewise definition for a function like absolute value. Okay, what we do is we split the definition of this function up into pieces, and each piece has an output. This is the output right here that is generated based on a particular rule about the input. Input rule. All right, and so here's how it works. If I were to ask you, and I'll get Joey to pick a number. I don't care what number you pick in the whole wide world. Pick a number. -47, okay? I need to check which input rule that falls under, okay? So which input rule it falls under? Is -47 greater than or equal to 0, or is -47 less than 0? Obviously, it's the second one, right? It's less than 0. So because this input rule determines, hey, I'm going to use this bottom piece, okay, then my output is going to read, okay, the opposite of what Joey told me. That's what that negative sign in front of X means. That means if I plug in X and it applies to the second piece, I'm going to my output is generated by taking the opposite of that input. So Joey told me -47. What's the opposite of -47? 47, and that would be the output. Okay. Now I'll ask Jack McBee, pick a number that's positive. 39. Okay. So that applies to that first piece, doesn't it? 39 is obviously greater than or equal to 0. So what does the rule say here? The rule says here, okay, just take whatever he gave us. Don't do anything to it. If X is the input, then X is the output. And so the absolute value of 39 is 39. The absolute value of 10 is 10. The absolute value of 1 is 1. The absolute value of 0 is 0. The absolute value of 42 billion is 42 billion. In other words, our output is the same as our input. We don't do anything different. but if the input that we got is negative, like Joey gave us a negative number, if we, in other words, have to use this second rule, then our output is going to be the opposite of whatever we looked at. Now that might, again, seem kind of like, well, you're making it overly complicated, Coach Morgan. Why can't we just think about it as those two aforementioned definitions? You know, the distance away from zero on a number line and the value of a number regardless of its sign. And so to answer that hypothetical question there, I'm going to roll down into this next picture, okay? So if I give you an example like, hey, you know, read what's the absolute value of 7, that's easy, okay? If I say, Will, what's the absolute value of -4, that's easy. But if I start talking about the absolute value of a variable expression, x minus 5, that's when we start getting a little bit more complicated, because, you know, how would you be able to describe for me how far away from 0 a variable expression is? You really can't, okay? And so what we want to be able to do is we want to be able to analyze it through the eyes of that piecewise defined function that we looked at up there at the top. Check this out, okay? I'm going to draw you a picture. Here's a number line, and right down in the middle of that number line is 0. So when I think about x minus 5, that's what we're taking the absolute value of, okay? X minus 5. If it applied to that first rule, okay? If it applied to that first rule, remember what our first input rule was? Greater than or equal to 0. Which side of 0 would it be on? If x minus 5 is greater than or equal to 0, would it be to the right of 0 or to the left of 0? What do you guys think? It's going to be over here to the right somewhere, okay? Maybe I'll plop it down right here. There's x minus 5, okay? And so therefore I would say, hey, look, the absolute value of x minus 5, its output would just be whatever its input was. So the absolute value of x minus 5 would be x minus 5 in that case. But because x minus 5 is a variable, remember variables are subject to change, we don't know, they're unknown. What if x minus 5 was a negative number? What if x minus 5 existed over on the left side of the number line? Okay? Then what would our rule be for calculating its absolute value? Anything that's less than 0, what do I do to that input?
You make it positive.
Make it well, we take the opposite of it, right? Remember we said you negate whatever that input was? So in this case, what would that look like? That would be the opposite of x minus 5 would be its distance, okay, away from 0. Because distance is never negative. It wouldn't make sense for me to say, hey, I live negative 32 miles away from here. That's cuckoo, okay? We say distance is non-negative. So when we talk about absolute value, it's important for us to understand that you can take the absolute value of a number, that's cake, that's you know, kind of baby steps. And then the absolute value of a variable expression, you need to consider both the positive, in other words, the as-is expression, and you also need to consider the opposite of that expression, okay? Now this will play into when we get into doing more like some inequalities work and solving some equations and inequalities that have absolute value in them. But that's just a basic intro for today. Y'all have any questions about absolute value before we move on down the road and send you guys packing? All right, go for it. Mr. Oh, my mouse is wiggling. Yeah, go ahead, Jake.
How do you know which side x minus 5 number line is on?
You don't. So you have to consider both options. That's a great question, okay? And again, not to put the cart before the horse, okay, but check this out. What if I gave you an example, guys, and I said the absolute value of x minus 5 equals, let's say, equals 9. We'll make a nice, easy equation out of that, right? What you have to do is you have to consider, okay, well, x minus 5 could be a positive number, and therefore over on the right, so I could just say x minus 5 equals 9, okay? Or I could say the opposite of x minus 5 equals 9. That's where we're taking into consideration both of those scenarios. And then you would go through and you'd solve out and you'd get you know, your answers. What would this answer be? 14?
Mm-hmm.
x equals 14, and then x equals -4. Right? And like both of those would be true if I plugged them in. I mean, you go ahead and try it yourself, right? Plug them in, and both of them make a true statement when you plug them back in for x in the original equation. But the idea there, Oxley, really good question. We don't know if it's on the right side by itself or if it's on the left side, so we have to account for both scenarios. We have to consider both possibilities. And again, you guys do not have to know how to do that just yet. I've taken baby steps with you guys, so this is just a little extra icing on the cake. But for right now, we're just introducing the notion of absolute value so that when it comes up in this next section, you'll be able to understand it. All right. I gotta send you guys out of here. Live Jesus in our hearts
Forever.
Awesome, and I hope to see you guys tomorrow. Thank you, fellas.